Few individuals have done more to elevate aging research on a global stage than our next speaker. Dr. Nir Barzilai is the director of the Institute of Aging Research at Einstein College of Medicine and the president of the Academy for Health and Lifespan Research. Let's give a big welcome to Dr. Barzilai.
Thank you. And congratulations, okay? Congratulations. It's nice to see young people moving our field. I actually want to say something about it. Look, let's say it like that. In the board of geriatrics, there is a question: is aging due to the environment or genetics? And the right answer is 80% environment and 20% genetics. It's wrong, okay? But that's the answer. But you know, if you could understand the genetics part, you could maybe protect from the environment, okay? I'm saying that just because 20% here are coming from the political arena and 80% are scientists. But I think you 20% from the political arena can actually help us solve everything, okay? So that's the first message. The second message that I have is that although I'm here as the president of the Academy, I'm also in the council of the Longevity Biotech Association. Oh, you don't hear me. Thanks. You can be less subtle. You know, I was like, I'm an executive on the Longevity Biotech Association. So a lot of you are part of the Longevity Biotech Association. Those that are not, please talk with Risa Starr, who's the executive director. It's by invitation only, but if we don't know you, maybe we cannot invite you, so we'll learn a lot about you. Example of what the Longevity Biotech Association is doing is, first of all, investors are coming to us and say, hey, you know, what is this field, what we could do? And we would like give them one of the hallmarks, and they would come back and say, so which company is working on this hallmark? We're actually doing investor meeting. There's an investing meeting that's coming in New York, so some of you are actually going to present, and we're going to get investors there. And the newcomers to the Longevity Biotech is a service that for any of you company that want to know if your drug that you're developing as a gerotherapeutic change the hallmarks of aging, will do it for you, for pay, but for a reasonable pay. And if you want to know if your drug is working on old animal, we'll do it for you. And if you want to know, get some more indications of where to go and what would be your target, we'll help you with that. So there's a lot of reasons and more to join the Longevity Biotech Association. So here is Risa. I want to make, mainly other provocations. So this is not working. Point for the politicians here, okay? Those are 4 siblings that were born in New York between 1910 and 1920. And what's impressive is they all got to be over the age of 102. Okay? So by the way, there's the genetics here, okay? But there's really exceptional longevity. The woman on the right, Helen, she lived to be 110, then 107 and 109. They were shocked when the little sister died at 102. Helen actually, when I met her, she was 100 years old in a New York apartment, and when she opened the door, she was smoking. I said, Helen, nobody told you to stop smoking? She said, all 4 doctors that told me to stop smoking, they died. They didn't do anything good with the environment. Okay, they were smoking, they were obese, and we have 750 people like that, and we have another big project that is, by the way, now helped by Chris, where's Chris and Matter, to actually recruit 10,000 centenarians because we find longevity genes in them, and that's another story. But the reason I'm really showing you this is because of this. We really were interested to see, are the centenarians getting sick when everybody gets sick, and they're just sick for longer, or is their lifespan and health span, does it go together? And you see here that after the age of 60, other people are starting to get sick, and you see the sickness up there on the top. And at age 80, maybe 10% don't have any of those diseases. But the centenarians getting the disease 20, 30 years later. And even at age 100, there are 30% of the centenarians that don't even take any drug. And some of them will just not wake up in the morning. And the point here is we have a model. Okay, we have example of people that can live not only healthier but longer. But this is even not the important part. The important part is they have compression of mortality, of morbidity. They die, they're not sick at the end of their life. They're sick very little at the end of their life. Even the CDC have watched the medical cost of people, the medical cost in the last 2 years of life of people who died at the age of 100, and the cost was third of those who died when they were 60 and 70. And if that's not enough to convince you about this concept of longevity dividend, came Andrew Scott, and he's a professor of economy in London Business School, and you should talk with him because he says, guys, you're out of your mind. You're telling me those guys are not in the hospital, so what? What are they doing? They're traveling, they're shopping, they're building things. They have 40% of the economy. So the economical value of this health is underappreciated, and I think that's one of the strongest cases that we have here to present. Okay, but this is not what is the message that I want to leave here, and I'm hoping, Eric, I'm hoping that Eric and I can give similar talks, and I think that you showed them those pictures, right? That you let me use about, you know, what do we, if somebody says, I'm aging, I want to do something, well, the first thing is to maximize or optimize all of those things. The second thing that actually people and longevity doctors many times do, and I think it's really, really wrong, is to think about nutrients or nutraceuticals. Okay, we know nothing about nutraceuticals. Okay, we know nothing about nutraceuticals because you don't do clinical studies in nutraceuticals. Sometimes you do, okay, but we know that. But we don't have clinical studies on nutraceuticals. We know, for example, from a paper published recently that followed 12 million people, 7 million people over 12 years, that nutraceutical increased mortality by 4%. And it really amazed us because people who take multi-supplements, and I think that's the problem, the multi-supplement that are antagonizing each other. I think people who are taking the multi-supplements are actually also exercising and dieting and doing other things, and still you can see a signal. And therefore, I think the responsible thing for us to do for now, well, I'm not saying those nutraceuticals are not important. They're just not studied, okay? I'm not saying that there'll be important nutraceutical for us to deal with, okay? But I think it's important to think about FDA-approved drugs for one disease, okay, that got approval for one disease, that went the safety and everything of the FDA and have shown to prevent other disease and overall mortality. Okay, so that's how it goes. If you have a drug like that, you want them to have two things. From a preclinical perspective, as was demonstrated here. First of all, to show that it targets the hallmark of aging. Actually, most of those drugs will target most of the hallmarks of aging. As was said before, the hallmarks are not necessarily the mechanism of aging, but if you target them, you target the other, your animal will live healthier and longer. If you want to see if a drug really targets aging, it'll change the hallmarks of aging. As I said, we're providing evidence for that. The second thing, and that was demonstrated also, you want to see that your animals live healthier and longer. Okay, the example there, the red line is regular rats, and the other rats were caloric restriction. That was 30 years of work of lots of our labs to show that was the control. How are things doing versus caloric restriction? And in fact, our field was obsessed with calorimemetic. We wanted to actually have calorimemetic drugs because we knew that to tell humans don't eat is not going to work. And that's where GLP-1 is, right? That's the best calorimemetic that we have now. And that's the result in animals. Okay, now from clinical point of view, we want to show that in a clinical study that is targeted to a certain disease, we get change in multi-morbidities. We also want to see that in the same drug that was targeted for several diseases, we have decrease in overall mortality. And it has to be clinical study, and it has to be relatively short. Clinical studies are years, but relatively short. So do we have examples like that? And this is the point. If we have examples like that, you have to say that to people, because people come to the Longevity Biotech Association and said, you have no success. Okay? And I think that's wrong. We have success. We just need better success. That's all, and we need more. And we need more drugs and more combination of drugs and more others. But I think we have success. How does success look like? So, for example, so we have 4 drugs. So we score drugs, and when I say we, it's a big team, and this is an ongoing project. Now we're having a bigger project, but we scored drugs on a scale of 12, 6 where for the preclinical and 6 for the clinical studies. We're going to change it because the clinical studies are coming so fast and so furious that we're going to change the rating now. If you notice, rapamycin didn't make it to the top because there's really a lack of clinical studies in the dose we want to treat. So we don't put it for now, not that it's not promising. And another, so those are, sorry, I went backwards. Another important thing is, just remember, some of those drugs are for certain diseases. Metformin is used for many things, but it's used for, diabetes. But metformin has been used last year in New York there was a little epidemic of COVID. It was used much more than for diabetes because there's a clinical study that showed that if you give metformin within 3 days of COVID, you have half of the rate of hospitalization, death, and 60% less long COVID. Okay? The point is that all those drugs have other effects. Metformin affects immunity, affects inflammation, maybe affects the resiliency of the body when it comes to a severe disease. Okay, so that's just back to the hallmarks of aging. How does it look? This is from ITP. Many of you know ITP. It's the multi-central study to study longevity in animals. And look at the top 2 because there are 3 centers. So look at the first 2 graphs that are representing the average, and you see that in male, which is on the right side, in male, longevity has been extended. A lot of the drugs have sex-specific effects. Okay, I want to tell you that all the drugs that I'm showing you now, all 4 drugs, don't have sex-specific effect in humans. But why there's sex-specific effect and in there's going to be sex-specific effect is a huge issue for us. And women live 4 years longer than men, and there's a lot of biology differences, okay? So it's going to be a problem, but not in the drugs that I'm showing you. So, for example, this SGLT2 inhibitor was developed for diabetes. And you gave it to diabetes, and investigators showed that it actually prevents chronic kidney disease. And so now they took people with chronic kidney disease, some diabetic, some not, and they showed that when they treat it, there's a 30 to 40% decrease in cardiovascular disease. And the right one is on overall mortality. And this is in 4,000 people in 32 months. It didn't take long to get signals of multimorbidities and overall mortality with this drug. And there are many studies like that. There's the same study in cardiovascular disease, with decreased cardiovascular disease and renal disease. Okay, so there's cross. Those drugs are affecting many diseases. And so if you have any one of those diseases and you take this drug, you have 30% less chances of developing a variety of other diseases and mortality. Now, I won't go on and give you, I'll just give one example of each. So that's SGLT2, another study with cardiovascular disease, 28% decrease. Metformin and heart failure, 30% decrease in outcome. Biphosphonate and cardiovascular disease, 33% decrease in outcome. All clinical studies. Another GLP-1, 22% in renal outcomes. All of them are protecting other diseases. And the same with mortality. 32% of any cause of mortality, metformin in mortality of diabetes with arterioembolism, biphosphonate with ICU mortality, and 43% decreased mortality with GLP-1. Okay, so there's huge amount of data, and we're now looking also at the quality of data, and we're starting to write many papers for you guys, not for you guys, you know, but for guys to realize. I gave a talk at the American Association of Physicians yesterday, and it was a real success because they were amazed of the data. They haven't thought about it from the perspective of aging, but for diseases. Now, the nice thing is that it's legal. It's legal for doctors to prescribe FDA-approved drugs. The repurposing is done all the time. Metformin itself was first used for obesity. It's not a great drug for obesity. Not everybody loses weight, and if you lose it, you lose 5 and 10 pounds. PCOS is the main drug of choice for polycystic ovary syndrome. It's the main drug of choice for prediabetes. There's a clinical study on that. And it's given to macular degeneration. So why not give it for aging? Okay, those concepts are there. They're legal. FDA approved are safe. You know what's going on with them. There's still every one of those drugs, every one of FDA approved drugs can save 100 and kill 3. I'm just taking numbers, right? We have to choose the 100 better, and we have to prevent the 3, or know when to stop or what to measure. But they're okay. I thought that I'm enthusiastic enough so that my voice carries, but I'll come back. I'm really done. I want to say for the politicians, just things I don't want to forget is that aging is not only about older adults. Okay. People who survive cancer are aging. If we give them chemotherapy or radiation, we age them. People with HIV, it's probably the drug dependent, but they age, they get diseases 10 years before their cohort. People who are disabled. Hey, people who are poor, all over, right? In every country, poor people die 30 years before the rich people. And if we want to go to Mars, we have to stop aging. We're not going before that. And you know, and some of those gerotherapeutics are also treatments, like Down syndrome is an aging. There are some indications. Geroscience is influencing agriculture too, because you know shelf life of vegetables and fruits is also important. So we are everywhere. We just need the chance to get there. And the second thing is, look, it's not for the rich. This is a concept. Metformin is the cheapest drug in the U.S. formulary. Every health span, every company that has you know hospitals and clinics and stuff, if they would use metformin within 2-3 years, they'll get less diseases. You know, they wouldn't say no, we don't want to get it, and the other drugs will get. It's like all the time. They're expensive. They run out of patent. They're generic, and they become cheaper. There'll be some treatments that will be more expensive, but that's how it goes. You know, liver transplant hasn't become cheaper with time. Okay, there will be things like that. But so I think the bottom line is, guys, we have success. Okay, maybe it's not our success. Maybe it didn't start with biotech, but to say that we don't have drugs that show that they prevent age-related disease of mortality is not right, and it's working in our favor. We just have to make it better and more, and we have to get to the age of 100. Thank you. I should say just that those studies that I just showed you are also an opportunity for us to look at biomarkers, because not only those studies have done and showed outcomes, but we can take biomarkers that happen within a year of treatment and show not only what are the biomarkers of aging, but which one are changing within a short time. And this is a thing that we're working, we hope to work with ARPA-H.
I'd love to talk about brain-based biomarkers later, but my question is, I really like that you opened your presentation talking about this family that all became centenarians, do you have in mind your poster child? Who is someone that we can orient a campaign around to show, look at this person, how successful they've been. Now we want to take it the next step further.
We have American Federation of Aging Research, another head of mine. Okay, Steve is the scientific director, and Michael is in the board. There are several other people here. The American Federation of Aging has a study that's called Super Agers, that is recruiting 10,000 people. Oh, and Lee, is Lee here? You can talk with him. Lee Nutley. Super Ager family study where we're trying to recruit 10,000 centenarians. We started phase 1, it went really well. And inside we have spokesperson. The spokesperson are some of them are filmed, some of them are available. They're changing because, still at 100 years old, they're at the end of their life. It was incredible what brought them here, but they're at the end of their life. But we have access through American Federation of Aging Research. We can get you, if you want to interview somebody, if you want to make somebody a poster child, we'll get you.
Thank you.
Question for you, Nir, over here. So, with your supercentenarian data set, what was the cause when they finally did die? Because you mentioned compressed morbidity. What was their cause of death?
That's a great question. And there was a German study. And I'm saying German because it's very Germanic. They did it really well. They took centenarians who died at home versus other people at other ages that died at home. Because in the hospital, we kill them, right? And the title of the study was, "There's nothing special about centenarians," okay? They die for the same thing. But 40 years later, it was totally a delay of aging, okay? The thing in our experience, though, for example, I have a centenarian who at 102 got urinary bladder cancer. She had survival of 3 months, but she lived for 2 years more, and she didn't die from that. So there's lots of weird things that are going. Also, I have stories of centenarians that somebody decided to take them to the hospital, and in the hospital they did something that almost killed them, right? So you don't want to take centenarians to the hospital either. But basically, centenarians have genes that slows aging, okay? And that's why they can live longer.
So aging and death is one of, looking at organ failure like the heart or kidneys is one of the things most of the studies have focused on. But what I'm most interested in is like the senses that are not going to kill you. For instance, loss of hearing. Pretty much everybody old loses their hearing. Their night vision goes, their loss of smell, loss of taste, loss of the ability to run the same speed that they were doing, 20 years ago. Had any of the studies measured that?
Yes, absolutely, and that's very important. Look, it's a very important question, so let me make a few comments around it. From an FDA perspective, what I showed you is very important. They're interested in major diseases, okay? We have other things that we're measuring as part of aging, and our hypothesis is that those drugs didn't only affect major diseases, but the rate of aging. As an example, I gave metformin. All of a sudden, metformin is used for macular degeneration. There's a connection. It's the same drug that does diabetes and other things, and it's also protective of the eye. So I think a lot of them are doing that. I will tell you another thing. Not all the drugs in the cellular level do everything or everything together. For example, metformin, we measured what metformin does in 22 different tissues. It doesn't do everything in all the tissues. And others maybe are doing. So there's a lot of discovery to do, but I think we'll have enough drugs and enough knowledge to understand what the drugs are doing for many causes, but also for our senses and all the things that have to be with quality of life.